This is the explanation video for the solar stew lab. So 4.6 billion years ago, there was a solar nebula, and that was just a cloud of dust and gas. It eventually condensed to form our sun, and then other materials left over formed the planets. More dense material stayed closer to the sun, and less dense material was moved a little further away, and it formed things like the gas giants. So, the purpose of this lab is to look at the densities of common substances on Earth and then compare them to the densities of planets in our solar system so you have a better understanding of the density differences of our planets. You should remember from physical science that density is the amount of matter in a specific space, and we can calculate it by taking the mass of an object divided by its volume. If you were completing this lab in person, you would use the volume by displacement method. So what we do for that is we put some water in a graduated cylinder. We take the initial volume reading, and then once we drop in our object, for example, this is acrylic, you will see that the water level increases, and I can find the volume of that object by taking the final volume minus the initial volume. I've already collected data for you here. Some of these materials you might not be super familiar with. So for example, this is magnetite, it's a mineral. This is sphalerite, another mineral. And this is chalcocite, another mineral. Other objects you're probably a little more familiar with, like iron, cork, clay, acrylic, things like that. I've given you the mass. I used just a scale to take that. And then we did volume by displacement to get the final volume and initial volume for all of these objects. To calculate the sample volume, you'll need to do final minus initial volume. And then to calculate the density, you'll need to take the mass and divide by the sample volume. You'll need to do that for all of the stew samples in your data collection table. Once you have calculated the densities, you'll be able to compare them to the densities of the planets in our solar system. You might not get exact matches. So for example, the density of Mercury is 5.4 grams per cubic centimeter. You would try to find a stew sample with a very similar density. You might use a stew sample more than once, and there may be a couple that you don't even get a match for with our planets. Once you've completed your data analysis table, you're able to answer your post-lab questions. If you have any further questions, please reach out to your teacher for further assistance.